538. So I have highlight going on. I have information from the previous page where I highlighted and I made a list. This page is super colorful because there's a lot going on. In the table for question 5, I am focusing on triangle ABC, and I figured out the side opposite angle A and the hypotenuse create this ratio, and from the previous previous 2 videos worth of work, they come up with a ratio of 0.7. So does the side adjacent angle A with its hypotenuse. They come up with a ratio of 0.7. So then that leaves us with the third ratio of the 2 sides, the side opposite angle A divided by the side adjacent angle A, but they happen to be the exact same number. So when you have a number divided by itself, the ratio results in a 1. Then we need to now look at the small triangle. So in the small triangle, ADE, there is a side opposite angle A. Just to remind you, that would be this one, DE. And the hypotenuse is AB. So our fraction, our ratio written as a fraction, would be DE divided by AD. So looking at the previous page, finding that fraction, we have DE, as I wrote the letters in reverse order, but it's this fraction, ED, AD, and the result of that ratio is 0.7. Okay. Continue on. The side adjacent to angle A in this triangle would be AE. Still, AD is the bottom, and it has the ratio of 0.7 right here. I use EA, AE. It's in the game. Last of all, we have the side opposite angle A, so DE, and the side adjacent to angle A, so AE, and they were the same length, so they have a ratio of 1. These are not magic. These are just what we measured, and they're going to be consistent. So if anything, I'm going to say this table can become a reference table for us in the future. Gabriel is asked to weigh in on this one. Gabriel says, the side length ratios of the opposite side, lot of color, lot of color, to the hypotenuse, or the adjacent side to the hypotenuse, is a percent. We didn't write any percents down, so I guess I'm kind of pondering, like, why would Gabriel say this? If the ratio is approximately 0.7, yep, we got that. We got 0.7. That means the length of the side is about 70% of the length of the hypotenuse. Is that what this means? This 0.7 could be written as 70%. So, however long the hypotenuse is, the opposite side will be 70% of that amount. Yeah. Okay, that's what ratios do. Ratios create a comparison of a part to a whole. Sorry, you're not seeing what I'm writing. Ratios create a comparison of a part to a whole. So, if opposite side divided by hypotenuse is 0.7, then that means that 70% of the hypotenuse is the opposite side. And likewise for the adjacent. Nice job, Gabriel. Good observation. Thank you for watching this video. This has been page 538, thinking about the ratios of sides in right triangles, where you compare the opposite to the hypotenuse or you compare the adjacent to the hypotenuse. That is going to be the bulk of this entire month of videos and notes and lessons on an amazing concept of trigonometry. Dig in, figure it out. You've got this. Next up, page 539. Thanks for watching. Bye.